Hello, welcome to part 2 of our lecture series on how to measure the nation's income. In part 1, we looked at what GDP was and what constitutes GDP. In other words, the components of GDP. In this part, we'll seek to answer two main questions. The first one is, how is GDP corrected for inflation? And the second, does GDP measure society's well-being? So GDP can be measured in two ways. We can measure what is called nominal GDP, and we can measure what is called real GDP. So nominal GDP values output using current prices. So current prices here represents the prices you get for goods and services on the market at any particular point in time. And this type of prices or this type of GDP is not corrected for inflation. And we know that inflation represents the general price level in an economy. Now, unlike nominal GDP, real GDP values output using the prices of a base year, okay? And real GDP corrects for inflation. At the base year, nominal GDP and real GDP will be the same. Let's consider this example. So if the only two items that are produced in an economy are pizza and coffee, then what is the GDP of this country for the 3 years starting from 2014, 2015, and 2016? And we are required to compute the GDP for each year. So for each year, the sum of the value of pizza and coffee produced will constitute the GDP for each year. So for 2014, the value of pizza is the quantity of pizza produced times the price for each. And the value of coffee is the quantity of coffee produced times the price. Okay, so mathematically, we can express this as shown above. So the value of pizza is 10, which is the price, times the quantity, which is 400, plus the value of coffee, which is $2 times the quantity, which is 1,000. The result gives us $6,000. So in the year 2015, we can equally compute the value of GDP by following the same procedure, and we can see that it is 8,250. In 2016, it is $10,800. Now let's look at the percentage increase in the GDP between the years. So between 2014 and 2015, the GDP increased by 37.5%. And between 2015 and 2016, the GDP increased by 30.9%. Let's consider another example. This time we are required to compute the real GDP in each year using 2014 as the base year. What this means is that the previous example was on nominal GDP. So the base year's price for pizza is $10, and the base year price for coffee is $2. So in 2014, the real GDP would be 6,000, just like the nominal GDP, as we said earlier on. However, in 2015, the GDP is no longer the value we obtained for the nominal GDP, we can see that it is 7,200. And this is because the prices we are using are the same as the 2014 prices. The only thing that changes is the quantity. And in 2016, it is $8,400. Now, let's consider the percentage increases based on the real GDPs we've computed for each year. So between 2014 and 2015, real GDP increased by 20%. And between 2015 and 2016, real GDP increased by 16.7%. Now, in this table, we compare the values we've obtained for nominal GDP and real GDP, and we can see the differences based on the different approaches we used in computing them. So in 2014, real GDP and nominal GDP were the same. In 2015, we saw that nominal GDP was higher than real GDP. In 2016, it was also higher than real GDP. So in each year, nominal GDP is measured using the then current prices. Real GDP is measured using constant prices from the base year, which in this example is 2014. So let's look at comparing the percentage increases we computed earlier on. As you can see, between 2014 and 2015, real GDP increased by 37.5%, whilst nominal GDP increased by 37.5%, while real GDP increased by 20%. And between 2015 and 2016, nominal GDP increased by 30.9%, and real GDP increased by 16.7%. And you can see that real GDP is lower because it has corrected for inflation. Or basically, we have deducted the effect of inflation from it. So the change in real GDP is the amount that GDP would change if prices were constant, i.e., or that is if there is zero inflation. Hence, real GDP is corrected for inflation. So this graph shows you the nominal and real GDP in a country like the US from 1965 to 2015. Another concept that is interesting for us to consider is the GDP deflator. Now, the GDP deflator is a measure of the overall level of prices in an economy. And you can compute this GDP deflator by multiplying 100 by the ratio of nominal GDP and real GDP. And we can say that the GDP deflator measures the current level of prices relative to the level of prices in the base year. Okay. So in looking at the economy's inflation rate, we are saying that the GDP deflator computes the percentage increase in the GDP deflator from one year to the other. So I'll take this again. The economy's inflation rate actually computes the percentage increase in the GDP deflator from one year to the other. So let's look at an example of how to compute the GDP deflator in each year. So we have this table from year 2014 to year 2016, and we have nominal GDP and real GDP. What is the GDP deflator? So for 2014, GDP deflator is 100 times the GDP for the nominal GDP for 2014 divided by the real GDP for 2014, and the result is 100. For 2015, the GDP deflator would be 100 times the nominal GDP divided by the real GDP, and it gives us 114.6. And for 2016, the GDP deflator is 128.6. We can see that in terms of percentage change, the GDP deflator increases by 14.6% between 2014 and 2015, and it increases by 12.2% between 2015 and 2016. At this moment, let's consider this active learning example. Now, I have data on two goods, good A and good B. I have their prices and their quantities for 3 different years, 2014, which is the base year, 2015, and then 2016. Now, we are required to use the above data to solve these problems. So A, we are required to compute the nominal GDP in 2014. B, we are required to compute the real GDP in 2015. And C, we are required to compute the GDP deflator in 2016. Now let's consider the answers to these questions. So in computing, for A, in computing the nominal GDP in 2014, we need to find the value of both goods, good A and good A and good B. And we'll find their values by multiplying their quantities by their price, their respective prices. So for good A, the value of good A is the price, which is 30, times the quantity, which is 900, plus the value of good B, which can be computed by multiplying the price of 100 times the quantity of 192. And then that gives us a GDP of $46,200. For good B, or for question B, would compute the real GDP in 2015 by multiplying the prices for 2015 by we would actually compute the value of each of the goods, good A and good B, by multiplying the base year prices by the new quantities in 2015. So the base year price, which is the prices in year 2014, is 30 for good A and 100 for good B. The quantity of goods for good A in 2015 is 1,000, and that for good B is 200. And so if we multiply 30 by 1,000 and add 100 times 200, that gives us a real GDP of 50,000. And then in question C, we are required to compute the GDP deflator in 2016. As we said, we can compute GDP deflator by multiplying 100 by the nominal GDP divided by the real GDP. So what this means is that we need to find the nominal GDP in 2016 and the real GDP in 2016. So we'll compute the nominal GDP in 2016 by multiplying the current prices in 2016 by the quantities of each good. And as we can see, the current price for good A in 2016 is 36 and the quantity is 1,050. For good B, the current price is $100 and the quantity is 205. That gives us a nominal GDP of $58,300. For real GDP, once again, we would use the base year prices and the new quantities in 2016. So the base year prices, once again, are $30, which is the price for good A in the year 2014, and $100 for good B in the year 2014. The quantities for good A and B in 2016 are 1,050 and 205 respectively. So therefore, our GDP deflator is 100 times the nominal GDP divided by the real GDP. So we'll substitute the earlier figures we obtained for nominal GDP and the real GDP, and that gives us a GDP deflator of 112.1. So at this point, we have acquired some knowledge about how to measure real and nominal GDP. Now, it is important to know whether GDP measures economic well-being, which is the most important thing, or one of the important things that every economy seeks to do. We'll look at this question in part 3. Thank you for watching.